Welcome to Alphanumeric Tricks. In this video, we are going to see how to get the solution of first order nonlinear partial differential equation problems. Okay. Under that, we are going to see how to get the solution of type 3 problems, that is case 1 f of x comma p comma q is equal to 0 type of problems. In last video also, we have seen that how to get the solution of type 2 problems, that is Clairaut's form type of problems. The link is available in the description box. If you want, please have a look on it. Now we will see how to get the solution of these two problems under the type f of x comma p comma q is equal to 0. Okay. Now we will see the first problem. Solve p is equal to 2 into q x. Here in this problem, p is there, q is there, and x alone is present. Say these variables alone is present. So your problem is of the type f of x comma p comma q is equal to 0. Okay, so identification of the problem is very important. Once you identify the problem type, using corresponding working procedure or working rule, we can easily get the solution for first order nonlinear partial differential equation problems. Okay, now the given problem is taken as number 1 and we have to find out the solution for this. Here the solve is there, that is a problem is asked to solve, so we have to find out complete integral, singular integral and the general integral. Okay, before going to start with complete integral, we will write the problem is of which type. So this is of the form f of x comma p comma q is equal to 0. Okay, so after identifying the type of the problem, you have to recollect your working rule for complete integral. Okay, so how will you, what is your working rule for complete integral? First you have to substitute q is equal to a in the given problem to find the value of p, and then the value of p and q are substituted in dz is equal to pdx plus qdy, and integrating that we can get the complete integral. This is the procedure. Okay, so first we have to make use of the substitution q is equal to a in the given problem. How you remember the substitution is, in this problem x and p are related, that is only three terms are present, x, p and q. Here x and p are related because p is dou z by dou x. So and the separate term is a q. For this q we have to make use of the substitution. Okay, then your given problem becomes p is equal to 2 into q is replaced by a into this x. Now the values of p and q are readily available. Substitute this in dz is equal to pdx plus qdy. Okay, so substituting dz is equal to p is 2ax and dx plus q is a into this dy. Okay, integrating this you can get the complete integral. So integrating integral dz becomes z, because a differentiation integration get cancelled, so we get z alone is equal to integral of 2ax dx plus a dy. This is under the integral sign plus this constant of integration. Okay, so now we have to integrate this term. What is integration of 2ax dx? 2a is constant, so write as it is. Integration of x dx is x squared by 2 plus a into integration of dy is y plus this constant of integration is c. Now this 2 get cancelled. Okay, this 2 and 2 get cancelled. So what is the remaining term? Is it is equal to ax squared plus ay plus c. So which is the required complete integral. Okay, number that equation as 2. In this complete integral we have two arbitrary constants are present and the number of independent variables is also equal to 2. So this is our complete integral. Okay, now using this complete integral we have to find out the singular integral. Okay, so this complete integral is z is equal to ax squared plus ay plus c. What is the working rule for finding singular integral? That is This is similar for all type of problems. Only working rule for complete integral is different. Singular integral and general integral working rule is same for all type of problems. Okay, now what is your working rule? First you have to differentiate this complete integral partially with respect to the available arbitrary constants a and c, and using the rule dou z by dou a is equal to 0 and dou z by dou c is equal to 0, we have to eliminate the arbitrary constant to get a singular integral. Okay, and whenever your C is separately there in your complete integral and such type of problems, there is no singular integral, because when you differentiating this with respect to C partially, then we get dou z by dou c is equal to 0. Using that rule is equal to differentiation of ax squared with respect to c is 0 because it is constant. Differentiation of ay with respect to c is 0, that is also constant, plus c with respect to c is 1. So 0 is equal to 1. Result is obtained, which is an impossible result. So in that case, we need not to find out the differentiation with respect to a, because we can't eliminate the arbitrary constant using the differentiated term and the observed result. Okay, so that's why we conclude our result as there is no singular integral for the given problem. Okay, this you should remember. Okay, so here there is no need to find out the differentiation with respect to a. Whenever your c in the arbitrary, there is arbitrary constant c in the complete integral is present separately. Okay, now we have to find out the general integral. How will you get the general integral, or what is the working rule? Same line, that is your complete integral to arbitrary constants are reduced to single arbitrary constant with the help of the substitution. C is equal to phi of a in the complete integral. You have to do it. How we are using this substitution is one constant in the complete integral is written as the function of another constant. So we can write c is equal to phi of a, or you can write a is equal to phi of c. So substituting into, we get z is equal to ax squared plus ay plus c is replaced by phi of a. Number that equation as 3. Now you have to differentiate this equation 3 partially with respect to the single arbitrary constant. Because of the substitution, your two arbitrary constant in the complete integral is reduced to single arbitrary constant. You have to differentiate that with respect to the constant. Okay, and then differentiating z with respect to a is dou z by dou a, but using this rule, that is equal to 0 is equal to ax squared. Differentiation with respect to a is x squared, because x squared is constant. A with respect to a differentiation is 1, plus ay differentiation with respect to a is y, because y is constant, plus differentiation of phi of a with respect to a is phi dash of a. Now using 3 and 4, we have to eliminate the arbitrary constant. We can get the general integral. This is the way you have to conclude your result. Because of this substitution, c is equal to phi of a, we doesn't know this value and we can't find out the that is, we can't simplify this equation further. Okay, so that's why we conclude your result like this, general integral like this. Okay, now we are going to see the next problem. Solve p squared plus q is equal to x. Number the given problem as equation 1. Here also p term, q term, x term is present. So this is of the type 3 problem. Under that case 1 problem, f of x comma p comma q is equal to 0. Okay, we have to follow the same lines to get the solution. First we have to find out the complete integral. Before going to start with your complete integral, you should write the problem type. That is, this is of the form f of x comma p comma q is equal to 0, and then you have to substitute. What is the substitution? Which term you have to substitute? For q. Yes, you are right, because x and p are related. So you have to substitute q is equal to a in the given problem. Then the problem becomes p squared plus q is replaced by a is equal to x. From this, q value is already known to us. We have to find out the value of p. Okay, So the value of p is obtained by, you have to take plus a to other side, it becomes minus a. So p square is equal to x minus a. From this p is equal to, so we're taking square root, from this p is equal to plus or minus square root of x minus a. So values of p and q are substituted in dz is equal to p dx plus q dy. So substituting here, dz is equal to plus or minus, p is replaced by root of x minus a into this dx plus q is replaced by a into this dy, are integrating, you get the value for z, that is integrating, integral dz is z, which is equal to integral of plus or minus square root of x minus a dx plus a into dy plus a constant of integration. Okay, now we have to write the integration of root x. What is root x? Root x root x integration is 2 by 3 into x power 3 by 2. That is the root x differentiation, integration. So here is the same way, we have to use integration of root of x minus a is 2 by 3 into x minus a whole power 3 by 2. Okay, that is using the formula x power n plus 1 by n plus 1. The power n here is half. X minus a whole power half, we have to write it half plus 1 by half plus 1. So half plus 1 is 3 by 2 divided by 3 by 2, you have to write it. But 3 by 2 can be taken as a reciprocal, so it becomes 2 by 3. Okay, plus integration of a dy is a into y plus this constant of integration. So this is the required complete integral for this problem. Here also we have two arbitrary constants and two independent variables. Now give this complete integral as 2. Now we have to find out the singular integral for this problem using this complete integral. Is it is equal to plus or minus 2 by 3 into x minus a whole power 3 by 2 plus ay plus a constant c. Okay, how will you find out? Using that rule, dou z by dou a is equal to 0 and dou z by dou c is equal to 0, because in complete integral the arbitrary constants a and c are available. So you have to use this rule and differentiate this with respect to the arbitrary constants a and c, but here c is separately there, so no need to differentiate this with respect to a. So differentiation of c is enough to conclude our result. Okay, so differentiating this with respect to c, we get dou z by dou z. By using this rule is equal to 0 is equal to differentiation of this term with respect to c becomes 0, because this is constant. Similarly, ay is also constant. Differentiation when you're differentiating with respect to c, that's why that is also 0 plus c with respect to c is 1. So we get 0 is equal to 1, which is an absurd result. So there is no singular integral for this given problem. That is the way you have to conclude your singular integral. Next we have to find out the general integral. General integral is also similar. We have to, that is 2 constant in the complete integral is reduced to single constant by the substitution c is equal to phi of a in the same complete integral. Okay, so then your complete integral becomes z is equal to plus or minus 2 by 3 into x minus a whole power 3 by 2 plus ay plus c is replaced by phi of a. Okay, that is one constant is written as a function of the another one. We have to write it. Number that equation as 3. And then after number this, you have to differentiate this with respect to the available arbitrary constant a. So when you differentiating this, you have dou z by dou a, which is equal to 0, because using this rule, differentiation of z with respect to a is dou z by dou a, which is equal to 0. Plus differentiation of this term partially with respect to a, we have to do it. So 2 by 3 into this plus or minus 2 by 3, you have to write it, and differentiation of x power, that x minus a whole power 3 by 2. So that is what is differentiation of x power n x power n minus 1. So n here is 3 by 2, right as it is. X here is x minus a whole power 3 by 2 minus 1 is 3 by 2 minus 1 is, you have to take the LCM. So 3 minus 2 by 2, which is 1 by 2 into differentiation of x minus a with respect to a. Differentiation of x with respect to a is 0 minus a with respect to a is 1. So that's why minus 1 is there, plus differentiation of ay with respect to a becomes y alone, because the y is constant, a with respect to a is 1 plus differentiation of phi of a with respect to a is phi dashed of a. Okay, this is the differentiated term number. This is at equation 4. Okay, from this these two terms get cancelled. So after cancelling this, you have to take 0 is equal to plus or minus x minus a whole power half into minus 1 plus y plus phi dashed of a number, that is equation 4. Now using 3 and 4, you have to eliminate the arbitrary constant a. We can get the general integral. This is the way you have to conclude your problem. Okay, that's all for this video. If you have any doubts in this, please provide in the comment section. Thanks for your time and thanks for watching. We will see in the next video. Okay, thank you.